Hello and welcome to another ramble with me. Uh, we are looking at question 7 from the department's May 2022 paper 2. And I won't lie, when I saw that this is going to be a question about trig graphs, I did heave a heavy sigh. So I think after this, I'm just going to take a break from trig graph questions because I'm over them. I am over them, to be frank. So yeah, let's relish the last trig graph video for a while. Potentially. Okay. In the diagram below, the graphs of f of x is equal to a half cos x. So that's a cos graph with an amplitude of a half. And g of x is sine x minus 30. So that's a sine graph that has moved 30 units to the right. Are drawn for the interval x is an element of the set negative 90 degrees until 240 degrees. A and B are the y-intercepts of f and g respectively. Okay, so the first question says, determine the length of AB. AB. So A and B. A and B are the y-intercepts of the graphs. So essentially, we just need to find out what those coordinates are. Oh! And then it's just the vertical distance, so that's easy enough to calculate. So let's see. The F graph is easy because we haven't moved left or right. So all that has changed is our amplitude. So that means that A is no longer at 0, 1, as it would be in a normal cos graph. It's now going to be at, 0 degrees and a half. Okay. And then for B, we need to be a bit more creative. So this is a sine graph that has moved 30 degrees to the right. So this used to be over there once upon a time. So the question is, where did you come from, my friend? Or we can just solve the equation. Well, not the equation really. We can just say, well, what is the value of the function when the angle is 0 degrees? Because, yeah, along the y-axis, x is 0. So that'll be sine of 0 degrees minus 30 degrees, which is the same as sine of minus 30. And we can just work that out on a calculator, but let's take the opportunity to exercise our reduction knowledge. So this will be the same as minus sine 30, and this is then the same as minus a half. So the coordinates here are 0 degrees and minus a half. So therefore the length of AB is a half minus a half. So that's a half plus a half, which is 1. Fantastic. Fantastico. So 1 unit is the length of AB. Let's see what's next. Write down the range of 3 times f of x plus 2. So if we were to stretch this graph by a factor of 3 vertically and then move it up 2 units, right? So currently the current range, or let's rather say range of f of x is from negative a half to positive a half. And the range of 3fx is going to be 3 times the boundaries. So negative 3 over 2 and positive 3 over 2. And then finally, the range of 3fx plus 2, we're going to add 2 to each of the boundaries, because everything is going to go up by 2 units. So even the boundaries will go up by 2 units. Okay. Whoa. Shrinking. Desperately required. Right. So that is the same as 2 minus 3 over 2. So that's 2 minus 1.5, which is a half. And 1.5 plus 2 is 3.5, which is 7 over 2, which is perfect. So that is the range of that new guy. You could alternatively sketch this. Yeah, potato, potato. Then they say, read off from the graphs a value of x for which g of x minus f of x is equal to root 3 over 2. I don't know, man. I don't know. How am I going to see the difference between things? No idea. No idea. Not a clue. G of x minus, okay, so the first clue is that the difference between them is positive. So this is a situation where G is above F, right? Otherwise, in a situation like this where G is beneath F, G minus F would give us a negative answer. So we are looking exclusively in this region here, guys. So where is the difference equal to root 3 over 2? Let's not even mention the fact that this graph is looking so blurry. So what must happen now? Am I just meant to trial and error? That doesn't feel right. It doesn't feel right. It don't feel right. It just don't feel right. G of x minus f of x is equal to root 3 over 2. Like, that's not even a value that you can properly see. You know, it's not like a half or 1 where you can actually count the blocks, you know. So, who tricky? A part of me feels like maybe at 90. I don't know. It feels like maybe at 90. So we can see that half of cos 90 is 0. And then sine of 90 minus 30 would be 60. Sine of 60 is root 3 over 2. So that's Bob's your uncle. So at 90 degrees, the value of f is 0. Okay. And at 90 degrees, the value of g is sine of 90 minus 30, which is sine of 60, which is indeed root 3 over 2. And so the difference between these two y values is indeed root 3 over 2. So lucky guess. Is there another one? I don't know. Do you want to try solve this? I don't know. Maybe we can solve it. Let's have a try. So we're looking for places where sine of x minus 30 minus a half cos x is equal to root 3 over 2. Like, I don't know how you're going to be reading off the graph that the distance is root 3 over 2. Like, how do you see that number? How do you know, this is an irrational number. It's going to be what? 0, comma something, something, something. Let's see what the calculator says. Oh, these questions sometimes, I don't know, guys. I don't know, man. You tell me how you're going to see root 3 over 2. 0,866 of a block. How are you genuinely going to read that off the graph? Hi, man, guys. Let's be real. Hi, let's be real. Oh, anyway, let's see how far we can get solving this manually. I am tempted to expand this. We're not distributing. Sorry, that was misleading. So I'm going to rewrite it using the compound angle identity and just see how far we get. Okay, so now I know that cos 30 is root 3 over 2 sine x, and sine 30 is a half cos x minus the half cos x from the graph. Oh my god. Right, is equal to root 3 over 2. So we end up with, oh, I'm gonna need some space. Give me some space. I ask for space. Thank you very much. Right. So this ends up being root 3 over 2 sine x, and this ends up being minus a half cos x minus another half cos x. So now we have a minus cos x is equal to root 3 over 2. It's giving dead end, but let's see. I'm gonna times the whole way through by by 2, sorry, so that I get rid of my fraction. Yeah, no, I don't really think we're going anywhere from here, guys. I don't think we're going anywhere. We ain't going nowhere. We ain't going nowhere. Because now what must happen? We can't factorize. If we take this to the other side, what are we gonna do? What are we gonna do? We can't use identities. There's no squaring happening anywhere. So it's just J, an unfortunate mishmash mosh, you know? So we tried, and this is where the journey ends. This is me partly refusing to accept that this is where the journey ends, but I have to accept that this is where the journey ends. So, you know what, maybe there is a way to solve it. I don't know, but the energy levels are giving Friday. Anyway, so next question. For which values or so sorry, so now the downside of this is that I don't know if there's another value in this interval that is going to satisfy this equation. I don't know. And this weird hunting expedition is a bit, it's just weird. Of just guessing, or just looking with my naked eye and looking for 0,866 of a block. I don't know about that, guys. I don't know. Anyway, so for which for which values of x in the interval -90 until 240 will f of x times g of x be greater than 0? So we're either looking at cases where both functions are outputting positive values or both functions are outputting negative values. So let us have a look-see. I'm going to go with my ruler. So over here, we have, what shall I do? Let me highlight so that it's easier for myself to see what is going on. So this is F. Oh, the betrayal of it all. And then this is G. Okay, so let's go with our ruler now. Oh, I literally just said. Okay, so over here, F is outputting 0 and G is giving us something negative. If we multiply those together, we're going to get 0. We don't care about that because we want instances where the product is going to be strictly greater than 0. So from here, we have F being positive, G being negative, and so it stays until the red crosses over to the other side. And that happens at 30. Now both blue and red are positive. So maybe let's just mark that for ourselves. Sorry, that might be useful. Okay, so hey, come back, ruler. Okay, so at 30, we now get F and G both having positive values. And then at 90, things change again. Blue dips into the negatives. So now from here, if we times them together, we're going to get a negative number, which is not what we want. So, okay, 90 is another critical moment on our journey, right? Then forward we go. Now we have positive and negative, positive and negative, positive and negative until red dips below the x-axis. And so we now end up with both red and blue outputting negative values. So the areas that work are this area over here, okay, because both F and G are positive there, and then this area over here, because both F and G are negative. Anywhere else, the one is negative and the one is positive, so multiplying them together would give us a negative value. So let us write this in words. So we either need X to be between 30 and 90, and we'll talk about the boundaries just now, whether we're including them or not, or between 210 and 240. Okay, so shall we include 30? No, because at 30, G is equal to 0. So if you times them together, you're going to end up with 0, not something greater than 0. So 30, as case my baby, not included. 90, same story. Now blue is 0. So if you times them together, you're going to get 0. So not what we want. If this has been including 0, then we would include those boundaries. So now let's look at 210 and 240. 210, same reason, we're not going to include it. However, 240, we are going to include because both of them are negative at that point. So our product will be something greater than 0. Lovely, isn't it lovely? Isn't it laugh, laugh? Isn't it wonderful? Isn't it precious? Okay, next. For which values of x in the same domain of these two functions is g prime of x minus 5 going to be greater than 0? My goodness, Dios míos. Also, just as a side note, we can test, we can sanity check these solutions that we got here. So what we are alleging is that if we choose any number in the interval that we outlined, and we put it into this inequality, it will hold. So if we pick 40 degrees, for example, because it falls in this bit of the interval, and we say half of cos 40 times sine of 40 minus 30, we should get a positive answer, and that we do. And if we were to take a number that is not in this interval that we've defined, so let's say we took 100, then we should get a negative number. So let's say we do indeed get a negative number. So just a bit of sanity checking that you can do. Anyway, back to G prime. G prime. Anyway, so we are talking about gradient. So the gradient of G, no, that's not G, G, we just highlight it because if I can get confused once, I can get confused again. I'm going to use a different color so that I'm not consistent because consistency sucks. Anyway, so we're looking at places where G prime, the gradient of this guy, well, not even of this guy, but of x minus 5 degrees would be positive. So for G of x, currently, we have a positive gradient from here up until here, and then it's negative from there. So if we were to move this to the right by 5 units, that would change where these turning points are happening. Okay, so let's figure out where the turning points are currently. So this is currently a sine graph that has moved right by 30 units. So on my OG sine graph, my turning points are at 90, this is 180, this is 270, And then on this side, this is minus 90. So if I'm to move this graph by 30 units to the right, then this is going to change to negative 60, 120, 300. So pretty much adding 30, sorry. So this turning point here would be negative 60. I mean, you can kind of see it, but it's always good to confirm, guys. Always good to confirm. And then this turning point here is 120 and 1. Okay. So if you were to again move it by 5 degrees to the right, then this turning point will now be at um, this will now be at negative 55 and negative 1, and this will now be at 125 and 1. So the gradient of this new graph would be positive when x is between these two, minus 55 and 125. So x would have to be between negative 55 and 125. And I think we don't include them because, yeah, the gradient at the turning points is exactly 0. And we're looking for where the gradient is going to be greater than 0. So I think a quick way that we can test this is you can look at what's happening to the graph, what's happening to the value of the function just before minus 55, just after minus 55, just before 125, just after 125. So if just before minus 55 we get a higher value than at minus 55, then that's promising. And just after minus 55 we get a higher value again. So then that tells us we went down and then up, which is what we want. And then here, otherwise, if it was still increasing here or something, then we would just get low value, slightly higher value, right? So we want evidence that this dip has happened, and we also want evidence that this dip has happened. So that's why I'm saying we're just going to test values around minus 55 and around 125. So so it's going to be sine of minus 55 minus, no, okay, let's choose a number slightly before minus 55. So that'll be minus 55.1 minus 5. Okay, so we get a negative 0.866. Okay, so we're going to need to remember that. And then if I say sine of minus 55 minus 5, okay, I'm going to need something. Okay, so you can see that the first one is slightly higher than this result. Okay, so that means, oh, I think I'm making this very complicated, but basically what that means is visually what we have is at minus 55.1 we got a slightly higher, did we got a more negative ratio. Eh, oh guys, minus 55.1 we got something over there, and then for minus 55 we got something higher. Oh no, it's a disaster. I was not expecting that. Okay, so now what happens if we say sine of minus 54.9, which would be over here, minus 54.9. Okay, and I minus 5. So that becomes minus 0.865. So that's also slightly less negative. So it's going up and up and up, meaning that the dip has already happened. Oh, so this is increasing now over here. This is a problem. Okay, so wait, sine of 60 minus 5, sorry, it's meant to be minus 60. And if I go slightly back from 60, what was that? Okay, and if I go back 0.91, 0.90. What is happening in this world? In this world, I am so confused, and I don't think it really helps that I'm crunching these numbers in a confusing way. Okay, let me try to explain my headspace. Okay, so I'm trying to test my assertion that when x is between minus 55 and 125, we are going to have an increasing graph. That's what this positive gradient means. So now specifically what I want to test is that over here at minus 55 is where we're going to get the dip, right? So we need to make sure that the number just before minus 55 is higher, as well as the number just after minus 55 is also higher, to show that we've gone down and then up. Okay, so now let me just write things down as well, because that might also ease some of my pain on these streets. Okay, so we are, I wish I had more options for where this calculator can be and not just either left or right. So we know that g of x is, sine of x minus 30. Okay, and then we know that g of x minus 5 is the same as sine of x minus 5. Just going to be super cautious here with all our operations, which is the same as sine of x minus 35. Okay, right. So the question that we are asking is, what is happening to the value of this function around minus 55 degrees? Okay, so let me actually draw this as a little table. Oh no. Again, honestly, we don't even need the very intricate. Okay, we can just say what's happening at minus 55, what's happening at minus 56, which is just before it, and what's happening at minus 54, which is just after it. Okay, so let's calculate these. Whoa! So we have sine of minus 56 minus 35, which is equal to minus 0, minus 0.999847, and so on. Okay, and then if we say sine of minus 55 minus 31, that gives you minus 35 gives us minus 1. Okay, and then if we look right after that, we have sine of minus 54 minus 35, which goes back to this number here. Okay, so what do we see? We see that So now if we really look at this properly, okay, what is happening is, okay, maybe let me not preempt it. So we have minus 56, minus 55, and minus 54. Okay, at minus 56, we end up with minus 0.99. Okay, and then at minus 55, we end up with minus 1, which is lower, slightly lower. And then at minus 54, we come back up a little bit to minus 0.99. So this is showing us that there is indeed that little dip that happens. And then from there, I mean, we can check what's happening at 54 as a sanity check, but we expect that it's going to be even higher than before. And we can see, yeah, that we're becoming less and less negative, kancane kancane, right? And then if we look at what's happening around 125, we're going to see the opposite. So if we look at what happens just before 125, so 124, we end up with 0.999847. Okay. And then at 125, we end up with a 1. Okay. So now we've gone from 0.99 to positive 1. And then if we go to 126, we should see it coming back down. And we see that it is coming down indeed. And if we were to go even further, no, man. Let's say to 135, then we see that, okay, it really is going down. So that is kind of a very informal way that we can check that the shape of this graph is indeed what we are expecting it to be. And it does look like, yeah, between minus 55 and 125, it does seem like there is going to be this increasing dynamic that we are expecting. Jeez, man, that really broke my brain, and I have a feeling I was putting in the numbers wrong. My bad if I was, my bad if you were spotting it and you just felt like reaching for me and punching me through the screen. Okay, don't punch people. That's not nice. But yeah, thank you for bearing with me. And as usual, I do hope that this was a fruitful, I don't like calling these things lessons, but conversation. And yeah, catch you another time for another ramble.